Alright guys, hopefully you got the first video. Now we are on to the second, finishing up starting with number 9. So number 9, we are going to, I'm actually going to push this up a little so you can see a little better. Sorry, trying to use small spaces here. Okay, so number 9. 5M, it's saying expand each expression. And remember, expand each expression just means this number on the outside of your parentheses, you use distributive property, which means if 5 is times m plus 3, it's the same as 5 times m and 5 times 3. So okay, so number 9, we are just going to expand it by saying if 5 can be times by m and 3, we're just going to write that out to show our work. 5 times m would just be 5m. 5 times 3 we know is 15. Then we're going to add it to 2 and use distributive property. 2 times m is 2m. We know 2 times 8 is 16. So we do our plus 16. Now we just combine our like terms. We rewrite them 5m plus 2m and 15 plus 16. And if we combine those, 5m plus 2m is 7m plus, and 15 plus 16 is going to be 31. That is our answer right there. So number 10, we're going to do the same thing too. I'm going to scooch over a little bit. 10, sorry, my book is falling on top of it here. Number 10. So we're using distributive property. If you're looking at your book, 9 times x, 9 times 2 is the same as what you're seeing here. So 9 times x is 9x, plus 9 times 2 is 18. Now we're adding 4 times 5 is 20, plus 4 times x is 4x. Now we combine our put our like terms up there, and we're just going to take and rearrange, remember how we do to show our work, 9x plus 4x, and then plus 18 plus 20, and now we combine them. 9x plus 4x is going to be 11x, plus, and 18 plus 20 is going to be 38. So that is our answer for that. Let's move on to number 11. Alright, number 11. I'm going to fold my page again to conserve some room. Number 11 has factor each expression, and remember, factoring is just breaking it down to find the common factor. So if we have 5 and 25, what is a common factor? Well, obviously we know 5 can go into 5 one time. 5 can go into 25 5 times. So I'm just going to kind of do exactly what they showed me as the original problem up here, and I'm going to say, okay, 5 is on the outside then. In parentheses, I'm going to put 1a, or it'd be more correct to just write a, because if 5 times a would equal 5a, and I put my subtraction sign, and I am going to put, well, if I have 5, what can I multiply it by to make 25? That is 5. And remember, the way we check this is we actually do the problem with our distributive property. 5 times 5, a is 5a. 5 times 5 is 25. Does it actually equal my original problem? Yes, it does. So we know we're right. All right, moving on to number 12. Number 12, again, we are going to say, what's the common factor between 7 and 28? Well, I know 7 can go into 7 one time, and it can go into 28 4 times. So 7 is my common factor that I will put on the outside. And in my parentheses, 7 times what is 28? 7 times 4. Then 7 times what is 7? 7 times, I could put 1x, but it's more correct just to put x. So the way I check it, 7 times 4 is 28. Take away 7 times x is 7x. Is that the same as my original problem? Yes, it is. So this is actually my answer. Don't get confused. I'm just these are the actual answers for that. We were just checking them down here. So number 13, same thing. This has more things that I need to find a common factor for. So what would be a common factor for 12, 28, 7, and 3? And our common factor for those is needing to combine my like terms first. So first, before I do that, don't start finding a common factor for all 4 of these. We actually have to combine them and then find a common factor for those. So we'll go ahead and rewrite our problem with our like terms next to each other. So 12z, and then I need to take my negative or subtraction from my 7z because that's to the left of it. Then I take 28 and I use plus because of my plus to the left of that. And then I take my subtraction from number 3, or from my 3, and now I can go ahead and combine them. 12z take away 7z is going to be 5z. I add 28 take away 3 is going to be 25. That's much easier to find a common factor for. So remember, don't look if it has multiple ones. Combine like terms first, and then it's much easier. So I know 5 can go into 5 one time, and 25 5 times. So my common factor is 5 that I write on the outside. And in parentheses, 5 goes into 5 one time, so I can put 1z, but it's more correct just to put a z. Plus, and 5 goes into 25 5 times. I check it by going 5 times z is 5z, plus 5 times 5 is 25. That is the same as this, so I know this is my answer. Moving on to 14. State whether each pair of expressions are equivalent. So I need to find out 3x plus 5 and 5x plus 3. Are those equivalent or not? Well, the way I do it is I go ahead and I say this is my distributive property. 3 on the outside of parentheses is the same as 3 times x and 3 times 5. So I will go for number 14. 3 times x is 3x. 3 times 5 is 15. So that's my first one. And 5 times x is 5x. 5 times 3 is 15. So don't be fooled here. It looks like it might work out the same because it's the same numbers, but if you actually work it out, it's 3x plus 15 and 5x plus 15. So it is actually not equivalent because those are not equivalent expressions. Number 15. 6y take away 26 and 2 times 3y minus 13. So 6y take away 26 and 2 times 3y is going to be 6y, and 2 times 13 is 26. Those are equivalent expressions. They work out to the same. So they are equivalent. Number 16, same thing. 18 take away 12p, and let's go ahead and just multiply this out. 3 times 5 is 15. 3 times 6p is 18p, plus 3 times 2p is 6p. 3 times 1 is just 3. So now we're combining like terms. So it will actually equal out to 18p plus 6p and plus 15 plus 3. Now we just combine our like terms. 18p plus 16p is going to be 24p plus 18. And is that equivalent to our original one here? 18 take away 12p? No, it is not going to be, because this is take away. This is plus. So there is no way we can go ahead and make those equivalent, because a takeaway is not going to be the same as plus, and so we can't switch those around to do that. So it is not equivalent for number 16. Number 17, folding my paper here, we'll do the same thing. 15 take away 5q, and 5 times q is 5q, 5 times 3 is 15. Those actually are not going to be equivalent because this is takeaway. If they were multiplication or addition, you can switch those around because 8 plus 5 is the same as 5 plus 8. But 8 take away 5 isn't the same as 5 take away 8. So if it's takeaway, we can't switch those around. Okay, so that one is not going to be equivalent because, again, we are takeaway, and takeaway can't swap those around. So 15 take away 5q is not going to be the same as 5q take away 15. So it is not equivalent. Make sure you don't get confused on those. If it's takeaway or division, it can't be swapped around. If it was addition or multiplication, it could. So number 18, I'm going to get a new piece of paper here. Number 18, Juan is G years old, and Eva is 2 years younger than him. So here is, sorry, I'm going to push this up a little. All right, 18. Juan is G years old, and Eva is 2 years younger than Juan. So younger would be taking away, so it would be take away 2. So this would be Eva's age. So Juan is G years old, that's his age. Eva is 2 years younger, so G take away 2 would be Eva's age. Now it says find the sum of both of their ages in terms of G. So if Juan's age is G and Eva's is G take away 2, we're just going to add those together to find the sum. G for Juan's, G take away 2 for Eva's would be 2 G's take away 2. That would be their age. And B is really confusing. I have no idea why they threw this one in here. It's not going over stuff that we have already gone over, so I am just going to say for 18B, do not do it. It's pointless. 18B, you do not have to do because it is silly. It's ridiculous. A big R for ridiculous. So number 19. Sorry. Readjusting here. Number 19. Parker bought 4 times as many marbles as Molly. Cole bought, so Parker, he bought 4 times as many as Molly. So we're going to have to wait until we find out what Molly's is, and Parker's is going to be 4 times whatever Molly's is. That's going to be Parker's. Cole bought 5 fewer marbles than Parker. So Parker, whatever this is, Cole's is going to be, sorry, looking at my notes here, Cole's is going to equal, Parker's will be 4 times something, and his is going to be take away 5 because it says Cole bought 5 fewer marbles. Now Molly, it says bought P marbles. So now we know what this is. We're going to fill in P because it says Parker bought 4 times as many marbles as Molly, which is P, and Cole 4P because that's what Parker's was, 5 fewer, and Molly's was P. So that tells us now we can go and answer the question, how many marbles did Cole buy? This is your answer right here. So I know this has been a very lengthy video, but I really want you to get a good grade on the test. So I'm going to pause it because it's almost to my 15 minutes and have you guys go to the second video for the last ones, 20 and 21. So see you on the second video.